Hi, so in this video, I'm going to show you how to integrate trigonometric functions using the various double angle formulae over here, okay? So we'll begin with integrating sine squared x with respect to x. So this is a very difficult integral to work out, but we can write it simpler using this sine squared x as part of this larger formulae. So we're going to make sine squared x the subject of this formula. So we'll move this term to the left and the cos 2x to the right. So we can say 2 sine squared x is equal to 1 minus cos 2x. Then we can divide both by 2. So this will give us 1 minus cos 2x over 2. So this is the integral we're going to find. So the integral of 1 minus cos 2x over 2 with respect to x is exactly the same as this integral here. So to integrate this, we're going to move the division of 2 out in front of our integral. So it becomes 1/2 of the integral of 1 minus cos 2x with respect to x. And we're going to focus next on integrating cos 2x. And we'll do this using the reverse chain rule. So we know the derivative of sine 2x is equal to 2 cos 2x. And we need to cancel out this multiple of 2. So we'll multiply both sides by 1/2. So the integral of cos 2x, because these two will cancel, will be 1/2 sine 2x. So now we can carry on with our integral. We have 1/2 of the integral of 1 with respect to x, which is just x, minus the integral of cos 2x, which we know is 1/2 sine 2x, plus the constant. Now we can expand out these brackets, so we get x over 2 minus 1/4 of sine 2x plus c. And this is the integral of sine squared x with respect to x. Okay, let's try question B. So we're going to begin by writing cos squared x using this double angle formula. So we'll move the -1 to the left-hand side. So cos 2x plus 1 will equal 2 cos squared x. Then we'll divide both sides by 2. And we get cos squared x is equal to cos 2x plus 1 over 2. But if you look now at the difference between cos squared x and cos squared 4x, you can see that the x, this one here, is mapping onto the 4x. So this 2x here will have 4 lots of that. So this will become 8x. So we're going to integrate the integral of cos 8x plus 1 over 2 with respect to x. And I'll just move all of this down over to here. So we'll begin by taking out this division of 2 out in front of our integral sign. So we have 1/2 of the integral of cos 8x plus 1 with respect to x. And we know that the derivative of sine 8x equals 8 cos 8x. And we can scale this by multiplying both sides by 1/8. So these two will cancel. So we can write this in our integral. We have 1/2 of the integral of cos 8x, which we know is 1/8 of sine 8x, plus the 1, which we integrate with respect to x, and we get x plus the constant c. So finally, we can expand out these brackets and we get the integral is 1/16 of sine 8x plus x over 2 plus the constant c. Okay, let's try one more question. In example 2, we've been asked to evaluate the integral of sine x cos x with respect to x. So the identity we're going to use is this identity here. But because we have 2 sine x cos x, we're going to cancel out this 2 by dividing both sides by 2. Then this becomes the integral of 1/2 of sine 2x with respect to x. Now we can move this half out into the front, so we have 1/2 of the integral of sine 2x. And to integrate the sine of 2x, we'll use the reverse chain rule. So we know the derivative of cos 2x will be equal to -2 sine 2x. We'll multiply both sides by -1/2. So now we know the integral of sine 2x will be -1/2 cos 2x. So 1/2 of -1/2 cos 2x plus the constant. And we can multiply this out, so this will be -1/4 cos 2x plus c. Okay? So let's try one more question. Okay, so finally, with example 3, we're going to evaluate the integral of sec x plus tan x all squared with respect to x. So the first thing we'll do is we'll expand out these brackets. So we have the integral of sec squared x plus 2 sec x tan x plus tan squared x, all integrated with respect to x. So now we're going to break these down into their separate integrals. We'll have this one in blue, this one in pink, and this one in green. So the blue one is the integral of sec squared x. And we know that this is a standard integral which integrates to give us tan x. Then the next one, we have 2 sec x tan x integrated with respect to x, where we can move the 2 out into the front, and we know this is a standard integral, and it integrates to make sec x. So this will be 2 sec x plus c. We should have a plus c here as well. And then finally, the tan squared x is not a standard integral, but we can write this using this identity here. So we can say we have the integral of sec squared x minus 1, all with respect to x. And again, we know sec squared x is a standard integral, and it makes tan x. And -1 integrated with respect to x gives us minus x plus c. So finally, we can collect these terms together. We have 2 tan x plus 2 sec x minus vx. And we can collect all of these c terms together to make one constant. And this is the integral for question 3. Okay? Thank you very much for watching, and I hope you found it useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.